Hey guys, Mr. Betts here. So I want to take a look at just a couple examples where we are decomposing an expression. So we're using linear partial fractions to rewrite this expression so the denominator has only linear terms in them. So first thing we want to do here is we want to factor the denominator. The denominator here is going to be x plus 3 times x minus 2. And so we're going to rewrite this expression then as two separate terms with x plus 3 in the denominator of one and x minus 2 in the denominator of the other. So keep in mind, if we were to add two fractions together in this form, the common denominator would be x plus 3 times x minus 2, or this right here. Now, the numerator is going to have only constants in it. So we're going to have an a here and a b here. You can use really any variable you want besides x because x is already being used here. Typically with these problems, we'll use a capital letter. And the idea then is we want to figure out what a and b are. In order to do that, we are going to get a common denominator. So that common denominator is going to be x plus 3 times x minus 2. So we have to multiply the first term by x minus 2. And we're going to have x plus 3 times x minus 2 in the denominator. And then the second term, we're going to be multiplying by x plus 3 over x plus 3. So I actually did a couple of steps here at once, but we get an expression that looks like this. So essentially, we just got a common denominator between the two terms here, and then add them together to get an expression right here. Now notice at this point that the denominator here and the denominator here are equivalent. It's just this one right here is in factored form. Some people at this point like to write this in the multiplied out form. It doesn't really matter. What matters is they're the same. So that means that the numerators are the same. So 2x plus 11 is going to equal a times x minus 2 plus b times x plus 3. And so to solve for a and b, what we're going to do is we're going to pick values for x that are going to make it easy to solve for a and b. So the first thing I'm going to do is I'm going to choose a value for x that's going to make the first term go away, 0, and that's going to be x equals 2. So when we plug 2 in for x, with this expression right here, we're going to have 2 times 2 plus 11, which I'm just going to write out as 15. The a is going to be multiplied by 0. That's going to drop out. I'm not even going to write that down. And then b times x plus 3, when x equals 2, is going to become 5b. So that's going to give us b equals 3. And then to solve for a, I'm going to make the second term go away, and I'm going to do that by choosing x equals negative 3. So we're going to have 2 times negative 3 is negative 6, plus 11 is 5, equals, and then negative 3 in here is going to give us negative 5a, and then the term with b in it goes away because that's going to be b times 0. So we get a equals negative 1. And so in the end, we're going to get an expression where we put a here, we put b here, and that's going to be equivalent. So 2x plus 11 over x squared plus x minus 6 is going to equal a, which is negative 1, over x plus 3, plus b, which is 3, over x minus 2. You can check this answer if you want by getting a common denominator here with this expression and checking to make sure that it simplifies to get that. Not a bad idea, especially early on doing this, to check your answer, check your work that way. So we'll go through another example. This one's going to be really similar. I'm going to start by factoring the denominator. Looks like it's going to be x minus 4 times x plus 2. So this is going to equal a over x minus 4 plus b over x plus 2. Then in this expression, we're going to get a common denominator and combine. So that's going to be a times x plus 2 plus b times x minus 4 is equal to x plus 2 times x minus 4. Okay, so again, notice that our numerators should be equal because the denominators are the same. So in order to solve for a and b, I'm going to choose x equals negative 2. So we're going to get negative 9. That's this expression evaluated at x equals negative 2 equals 0 times a plus b times negative 6. So b is going to equal negative 9 over negative 6, which is 3/2. And then if we choose x equals 4, that's going to make this go away. So we're going to have 8 minus 5 is 3 equals 6a plus b times 0. And we get a equals 3 over 6, or 1/2. So writing out our answer then, 2x minus 5 over x squared minus 2x minus 8 is equal to a, 1/2, over x minus 4 plus b, 3/2, over x plus 2. Now, this form right here is kind of nasty because it's a complex fraction, so we have a fraction within a fraction. So you could, if you wanted to, for example, write this as 1 over 2 times the quantity x minus 4 plus 3 over 2 times the quantity x plus 2. Then it's not a complex fraction. You don't need to do that. In fact, for the calculus we're going to do with these, it's actually easier if we just leave the fraction in the numerator like this. And we will be moving on and doing more from there. So we don't have to worry about the ugliness of those answers.